So this video is a quick overview of some of the work I did in Wise and Unity for the Wise Adventure game. So one of the things that I thought would be fun to incorporate into the game was a generative weather system that could act differently inside of the different map regions in the game. I started off by looking on the Unity Asset Store and I found Rainmaker, which was a free package that basically had a generative wind and rain particle system. And from within the script, I was able to connect up some Wise events and RTPCs that were able to trigger the wind and rain sounds from within Wise and also change their intensity through the RTPC. So in Wise, I set up a looping rain sound effect, and the volume of that is controlled by the rain intensity RTPC that is set up in the base script of Rainmaker. One thing that I wanted to make sure of was that any change in rain intensity didn't cause a sudden change in the volume of the playback. So I set the RTPC to filter over time just to gradually sort of slew the volume of um, the event. And I also set the playback limit to 1 just so that multiple instances of the event weren't triggered. Instead of using samples for the wind sound, I used the Wise Soundseed Air plugin, which had sort of more generative parameters for gustiness and wind direction, but the wind intensity again was controlled by the wind intensity parameter inside the base script. And then again, I just wanted to make sure that the RTPC was filtering over time so that there wasn't any abrupt change in wind intensity. And then it was finally just a matter of connecting the event to the sound effects and importing the Actimix hierarchy into the village and woodland sound banks, which were the two regions that I initially set up with the weather system. As you can see, Rainmaker exists within the audio region itself, just demonstrating how the effect is region specific. One of the problems I encountered with using regional sound banks was that the sound bank would often unload before the ambient sounds had fully attenuated. To prevent that from happening, I just expanded the regions and made a custom attenuator that made sure that all ambient sounds were fully attenuated by the time the sound bank had offloaded. I also wanted to make the windmill in the village react to the wind intensity. And to do that, the windmill had to be within the village audio environment so that I could connect it to the Rainmaker prefab within that environment. So originally the windmill sails just turn at a constant rate, but by connecting it to the Rainmaker prefab, I was able to make the wind intensity a multiplication within the rotation rate, so that when the wind intensity would increase, so would the speed of the windmill sails. Within Wise, I also wanted to make the sound of the windmill reactive to the wind intensity within the village, which I did just by connecting the wind intensity RTPC to the voice pitch and voice volume. In order to create more realistic footstep sounds in the rain, I created a footstep modifier, which is basically just a layer of walking and running footstep sounds in wet weather that play over the top of the terrain-dependent normal footstep layer. Again, they're connected to the rain intensity and player movement speed to create a more realistic sound. Another thing that I did with the project was incorporate a new AI NPC. And to start this off, I went onto Mixamo and downloaded a character with a few animations that I could import into Unity. Once I had those in Unity, I then set up the basic model and rig for that character so that I could connect the animations. In the animator window, I basically set up all the different animation states and connected those with Boolean conditions, and then attached the NavMesh agent to the model so that the AI character was able to walk on the appropriate terrain. Then I built a script to control the NavMesh agent as well as the animations, so that when the player was in a looking distance of the NPC was able to turn towards the player, um, chase them, and then when they were close enough, also attack the player. I then modified a version of the Evil Spit Plant script so that the enemy could be attacked by the player and also call wise events from within its animations. The red gizmo around the enemy just displays the look radius that the player must be in for the enemy to start the chase. The weapon impact, footstep, and enemy sounds were created using a mixture of personal field recordings and sound design. Using these recordings, I layered the different crate smash sounds and weapon strikes, also creating variation within those. This is the project for the Evil Spit Plant sound design, and in which I just created the sound design in response to gameplay footage and separated each sound into different regions. I also created a spawn sound effect that didn't exist in the original project, which involved going into the Spit Plant code in order to trigger that event. I also had to slightly modify the code to make sure that the sound wasn't re-triggered after the enemy was dead. Each region has a mixture of day and night ambient loops and events, which are controlled using the time of day RTPC. When a new event is triggered, it is randomly spatialized. I also created aux buses for each sound category, and on the ambience bus, I also included an effects bus for a convolution reverb. Using Excel, I created a categorized naming convention for all of my sound effects, which I then used within my Reaper regions before exporting them into the Wwise project using the WAPI transfer API, which is basically a way of transferring my sound effects directly from Reaper into Wwise without having to render them first. As you can see, they just appear into the selected containers within Wwise. And then once that's complete, I just go and check off each sound in my Excel spreadsheet. So finally, I wanted to build a plugin for Wwise within PD. And to do this, I set up the Heavy compiler so that it knew which version of the Wwise SDK I was using in the project. And then I went ahead and built a very simple sample rate reducer plugin inside of Pure Data. The receive object inside of PD can be accessed as a parameter within Wwise when the plugin is compiled. To compile the plugin, you just need to access Heavy through Python in the command prompt, which will then generate a Visual Studio solution. Using that, you can build the plugin in release mode, which will author the .dll and XML files that can just simply be transferred into the plugin directory of Wwise. Once Wise is open, the plugin should just appear in the list of third-party plugins. As you can see, the parameter then appears, which will be the sample rate reducer. And finally, the plugin just needs to be copied into the Unity directory. And from there, I can connect the player health RTPC back to my plugin so that the sample rate is reduced when the player health is low.